Okay, well, last video on the intro of the sum and difference rules, we're going to verify some identities. Um, and so we have several different identities. We're going to go through 4 different ones, many that you know and love, and we're going to use the sum and difference rules to do that. So first off, what we're going to do, just like when we did it in the past, is we are given this sum and difference. We have our sine of alpha plus another beta, 2 different angles, even though this angle is an x, it's still an angle. Now from here, we want to verify that this is true. So to do that, what we're going to do is we're simply going to just take this right here, and we're going to use the sum and difference rule to write it out. So this is a sum of 2 angles, and it's a sine, so we're going to take the sine of our alpha, which is pi over 6, and that's going to be times the cosine of our beta, which in this case is x, and that's going to be plus the cosine of pi over 6, all right, times the sine of x. Going from here, we know that sine of pi over 6 is going to be 1/2, all right, knowing one of our trigs. And we have cosine of x is cosine of x. Cosine of pi over 6 is going to be square root of 3 over 2, all right, square root of 3 over 2 sine of x. And guess what? If you factor out a 1/2 out of each one of these, which you can, you have is cosine of x plus the square root of 3 sine of x. And guess what we did? We just verified that the sum and difference rule applies and is equal to that. Cool, right? I know. Happy day. All right. Well, here's our cofunction identity, which we already know. The sine of 90 plus x is actually equal to cosine. Well, we're going to prove that now using what we have with our sum and difference rules. So once again, this is alpha, this is beta. To prove this cofunction, we can say the sine of pi over 2 is going to be the cosine of x plus the cosine of pi over 2 is going to be the sine of x. Just so we are over here, this is the sum of 2 angles. Sine of pi over 2 we know is 1 times cosine of x plus cosine of pi over 2, which we know is 0, times sine of x. Well, guess what? That's equal to cosine of x. Bada bing, bada la boom. That's what we found. Happy day with a little tongue. All right, let's try 2 more. Right here, we want to verify that this equals 0. Okay. Right here we have cosine of pi minus theta, and we have sine of pi over theta, or pi over 2 plus theta. I'm going to give us our little more room, so I'm going to put this other problem down on the bottom right here. All right, you can't see it. All right, we still won't go. I'm sorry. Okay, there we go. So right here, we have cosine of pi minus theta. So right here, we're going to take, and this is the cosine difference of 2 functions. This is going to be alpha, and this is beta in this case. And then we're going to take this sum, which we did before, which is going to be alpha and beta here. So we know that cosine of pi minus theta is going to equal cosine of pi times cosine of alpha plus sine of pi times sine of theta, not alpha, theta, or in this case beta. All right, then we go over here, and we already said this one, once again, the addition. So we know sine of pi over 2, we already know this is cosine, but we'll just write it out anyway. Cosine of theta plus cosine of pi over 2 times sine of theta. And doing this, cosine of pi is -1 times cosine of theta plus sine of that is 0 times sine of theta, which is going to be 0. So it'll cancel out. Plus, we know this is going to be cosine theta because that's equal to 1. And that's going to be 0. That's going to cancel out. And I'll just put one right here. And so what we have, these then will be added together. Negative cosine plus positive cosine. Guess what? That also turns out to be 0. Donut hole, sprinkles, happy face, tongue, and woohoo! That is what we want. Awesome, huh? Awesome sauce. All right, one last one. we want to verify that tangent of pi over 4 minus theta equals 1 minus tangent of theta plus 1 plus tangent of theta. Okay, so let's see if we can figure this one out. Well, we'll first off and write this out. We know that tangent of pi over 4 minus that is going to equal sine of pi over 4 minus theta, and that's going to equal cosine of pi over 4 minus theta. So now what we're going to do is we're going to multiply all this through, and we'll see what we get when we do it. Oh, that's a 0, that's a theta, sorry. So we have sine of that, and we have cosine of the difference. So let's check out our difference rules. I'm going to bring this down so we can use it. Maybe I'll just copy it. All right, clone it right there, bring it on down. Come on down. You're the next contestant on The Trig is Right. Okay. Okay, so now we have right here, bring that down as well. We have our difference of signs. Difference of signs right there. So it should be sine of pi over 4 cosine of theta minus cosine of pi over 4. And that's going to be sine of theta. On the bottom here, we're going to have cosine minus. All right, so cosine is going to be cosine of pi over 4 times cosine of theta plus we're going to have sine of pi over 4 times sine of theta. Let's simplify this. Sine of pi over 4 is going to be square root of 2 over 2 cosine of theta minus, that's going to be square root of 2 over 2 sine of theta. Right here, we're going to have square root of 2 over 2 cosine of theta plus sine of, oops, sorry, square root of 2 over 2 sine of theta. Going through, we can see that these, because we can factor them out, will cancel out because we can factor all those out right there. We then have cosine of theta minus sine of theta over cosine of theta plus sine of theta. Well, since we are trying to get ones right here, this one I'm going to go over here, I'm going to multiply top and bottom by 1 over cosine. 1 over cosine. Why are we doing that? So we can make this a 1 on both sides. Distribute that through, and guess what we have, my friends? Yep, 1 minus sine over cosine. Go a little higher, and this on the bottom we have 1 plus sine over cosine, which we know is actually the answer we're looking for, 1 minus tangent of theta over 1 plus tangent of theta. Neat. Okay. So, once again, going through and using the sum and difference rules, all right, to help us do identities. We've used them to simplify expressions. We've used them to find exact values of complicated angles. So sum and difference rules are very useful. And the next videos we're going to be talking about is how to use the sum and difference rules and to solve trig equation. So look for those videos coming up, but hopefully this helps you with your introduction to the sum and difference rules. Good luck and God bless.